Hello everybody, welcome to Guidancee Education channel. In this video, we are continuing class 11 physics chapter 12 thermodynamics. The topic discussed is first law of thermodynamics, then proof of the expression delta W is equal to P delta V. This video will be of great use to you, so watch the video completely without skipping. And if you think the video is useful, do like the video, share the video, and also leave your feedbacks as comments in the comment box below. If you are watching without subscribing my channel, do subscribe it now and support me. And also press the bell button and all button so that you get intimated as soon as new videos are posted. Thank you very much. Come, let us see the topic. We have already discussed internal energy, heat, and work. How are these three quantities related? Is there any method by which we can calculate change in internal energy? What is the significance of the relationship among internal energy, heat, and work? We shall try to answer all these questions in this video. The first law of thermodynamics helps us to answer these questions. Come, let us start. First law of thermodynamics states that the heat that is given to a thermodynamic system is used to increase the internal energy and also do work. It can be mathematically represented as delta Q is equal to delta U plus delta W. We have seen all these quantities in the previous video. If you have not watched that video, click the I button in order to watch them. What is the significance of this equation? Or before that, what does this equation tell us? If an amount of heat equal to delta Q is applied to a thermodynamic system, the system uses that energy to increase its internal energy and do work on the surrounding. So work is positive. Example, expansion of a gas. We have already seen that. Now, what is the significance of this equation? From this equation, we can get an expression for change in internal energy. That is a formula to calculate change in internal energy is equal to delta Q, that is heat supplied minus work done, is equal to change in internal energy. This is the significance of this equation, that is first law of thermodynamics. We know internal energy, which is the energy contained in the system, cannot be measured directly. Only change in internal energy can be measured. During pressure volume work, when the gas is expanding, its volume increases. Suppose we want to change the pressure and volume, the two state functions of a thermodynamic system, from P1 V1 to P2 V2. The first step is keep P1 constant and then change V1 to V2. Now, the state of the thermodynamic system becomes P1 V2. Now in the second step, keep V2 constant and change P1 to P2. Now the state becomes P2 V2. So in these two steps, we can change P1 V1 to P2 V2. Now the initial thermodynamic state of the system is different from final state of the thermodynamic system. Now, alternatively, that is, instead of following these two steps, in the first step, we can keep volume constant and then change P1 to P2. And then in the second step, keep P2 constant and then change V1 to V2. Whatever may be the path followed in bringing about the change in the state functions of the thermodynamic system, delta U remains independent of the path and it remains the same in both cases. Delta U is a state function and so depends only on initial and final values and is independent of path. During expansion work, V2 will be greater than V1. Then we say the gas has expanded. So the system has performed work. For calculating delta U, we consider only the initial state and then the final state, not the method by which this change in state is effected. I hope it is clear. Now we will pass on to see how work done is expressed in the case of expansion of a gas. Delta Q is equal to delta U plus delta W. Now let us see two special cases. In one case, delta U is equal to 0. What does it mean? A certain amount of heat is supplied, but the system is not using it for increasing its internal energy. That is, it is not absorbing any energy. All the heat that is supplied is utilized for doing work on the surrounding. Work is given as positive. So, when heat is supplied, and if the system is not absorbing any energy, and when all the heat is utilized for doing work, under that condition, delta Q is equal to delta W. This is case number 1. That is a situation. Now, let us see the second situation. Delta Q is equal to 0. What does it mean? The system is not supplied with energy. Then, from where it will get energy to do work? System utilizes energy from its internal energy. So, we shift this delta U to the left hand side. Negative delta U is equal to delta W. That is the energy needed for doing work is absorbed from the internal energy. A certain part of the internal energy is converted to work. So the final internal energy will be less than the initial internal energy. So when you calculate delta U, it will be a negative value. So this expression corresponds to a situation when heat is not supplied, but the system is doing work. So this is situation 2. Such questions are asked for the examination. That is, when is delta Q equal to delta W? When is negative delta U equal to delta W? The first one corresponds to isothermal expansion of gas. We will be learning that in the coming videos. I hope it is clear. Now we will proceed to prove that work done during expansion of a gas delta W is equal to P delta V. For that, we will see a diagram. This is a vessel fitted with a frictionless piston and it contains a certain amount of gas. This is the initial volume equal to V1. The gas expands and pushes the piston upwards. The final level of volume becomes V2. So, the difference in the volume is delta V. This is the height through which the piston has moved up. Having understood this, let us proceed to discuss the proof. Work done W we know is equal to F into S. We have learned this in mechanics. And F is equal to force and it is equal to pressure into area. It is the area of the piston that is considered. Work done is equal to pressure into delta V, that is change in volume. How is that? F into S becomes pressure into area into height. H is equal to S, the distance through which the piston moved. So, area into height becomes volume. So, work done is equal to P into delta V. Delta W refers to the small amount of work done. So, that equation is proved. This expression delta Q is equal to delta U plus delta W becomes delta Q is equal to delta U plus P delta V. From this equation also we can calculate delta U. I hope it is clear. Here work done is pressure volume work. When delta Q is equal to 0, negative delta U is equal to delta W. Then this equation becomes negative delta U is equal to P delta V. I hope it is clear. I hope this video was of great use to you. If you think the video was useful, do like the video, share the video with your friends who may also be benefited. And if you are watching without subscribing my channel, do subscribe it now. Subscriptions are totally free. And also press the bell button and all button to get intimated as soon as new videos are posted. Thank you very much for your support. We will meet in the next video with another important topic like this. Till then, bye. Take care.